Now we're going to be looking at some limits that are specifically at infinity. So here is a graphical interpretation. We've done a few problems like these, but we're going to kind of do a few more of them. So as f of x, so I have this function, and there's a picture of the function shown below here. As x approaches -1 from the left. Now I want to do it both numerically and then see it graphically, because I think that will help you understand like the relationship between the graphical picture of what you're seeing and the numerical way we calculate it. So if I were to say -1 from the left, you see the problem is when I plug in -1 here, right, I'm going to get 1 over 0 squared, which is 1 over 0. And that's some form of infinity, technically. It's either positive or negative infinity, and what matters is what the sign of the denominator is. So when I approach -1 from the left, see, what's going to happen is I'm going to approach a small negative number, because because a -1 from the left is like -1.5, -1.1, -1.01. So when I add 1 to that, it's still negative, but when I square it, it becomes positive, right? So this is 1 over a 0 that's like positive, and so this is positive infinity. And the squaring actually always makes it positive, so this is also 1 over 0 to the positive. It's positive infinity. And on the graph, we can see it approaches positive infinity from the left and the right. Okay, and so that's why those are like that. Okay, now let's look at this one. Now we're looking at some limits as x approaches negative infinity. And when x approaches negative infinity, again, numerically, if I were to look at this, it would be the limit as x approaches negative infinity, 1 over e to the x plus 1. Now, when x approaches negative infinity, I do write it as this. Even though this is not mathematically correct, this is what I think of it. Okay. Now, you have to think about what happens when e to a really negative big number is I don't think of them as, I don't like the negative exponents. I write them like this. Because one of my rules for exponents, I can put on the denominator, and I know e to this. And I know e to a really big number is a really big number. And 1 over a really big number is 0. So this becomes 1 over 0 plus 1, and that's equal to 1. Now graphically, we could say as I approach negative infinity, see this graph? See the y value approaches 1. How about positive infinity? Well, then that becomes 1 over e to the infinity plus 1. E to the infinity is a really big number. A really big number plus 1 is still a really big number. And so it's 1 over a really big number, which is 0. Now, mathematically, I wouldn't write it like this. This is just sort of illustrating. This is not correct mathematical notation. We're not really supposed to write 1 over infinity or e to the infinity. But that's how I kind of, intuitively see what's happening. Okay, now I'm approaching 0 from the left. Oh, and by the way, on b, you see, as it goes to infinity, see the y value approaches 0, which is what we got here. So see, when x approaches 0 from the left, okay, 1 over e to the 0 plus 1. E to the 0 is just 1, and so this is going to be 1 over 1 plus 1, and that's 1/2. And so when I'm approaching 0 from the left, it's going to be 1/2 here. How about from the right? From the right is the exact same operation. See, it didn't change the sign of this at all. It's still going to be e to the 0 plus 1, 1/2. So from the left and the right, it approaches 0 at 1/2 there. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.